Welcome to this early morning, not as early as other years, but welcome to the session. We're going to talk about authentication in Azure context. When it comes to authentication, I consider it mainly to be a security topic, but it is also a very core aspect of developing any modern application in the cloud. Any type of solution needs to have and consider proper authentication methods. When it comes to headlines, some people might recognize these type of headlines. These have flourished in the last couple of years, where someone has, in this case, Mercedes-Benz, for example, in January, accidentally exposed source code from a published password. We had SourceGraph last year with a leaked admin token, and Uber 2 years ago had a hard-coded secret in a PowerShell script that led to someone owning their entire cloud environment. Starbucks left an API key in a public repo, and even Microsoft had a test account in a test tenant that managed to be escalated all the way to read management mailboxes. This is human errors, mostly, and that's why it's so important for us to understand authentication. Also, partly why Microsoft went out and said that they're prioritizing security above all else a month ago. And when it comes to security, identity is the new perimeter. This might be something that you've seen in headlines. When it comes to protecting our network, identity is the new perimeter. This is a way of saying that when we are in the cloud, we are working towards public resources for the most part. So identity is the most important aspect that we have as a layer of protection. We need to trust the ones accessing those resources, because we no longer have our protected servers on our on-premises data center below ground somewhere. I mean, it's below ground somewhere else, but... So identity is the new perimeter. And if you haven't seen this headline, it's been pretty much anywhere. So identity is the new perimeter. Why is it so hard to defend? Because it's complicated. That's why it's so hard to defend. Before we get started, I want to take a moment to thank our sponsors, everyone making this conference happen year after year, and especially this year, because it's super fun to be here right now. So thank you to all the sponsors, all the organizers, and everyone helping out. My name is Emanuel Palm. I work as a cloud specialist at Unwanted in Sweden. We do Azure expert consulting within advisory, education, and mostly platform implementations. I love everything as code. I'm also a Microsoft MVP within developer technologies, and I have a few modules and tools open source. Most of them are for PowerShell. Some of them are written in C#, and I'm a big fan of open source in general. I have a GitHub and a blog called pipe.how, the blog that is. And other than that, I play Dungeons & Dragons. I like baking. I roast my own coffee. I do climbing and disc golf. And you can find me online at Palm Emanuel on the most platforms or off stage. My authentication journey started a little bit like this. From the bottom, I started working in Azure like 6 years ago or something, and I figured out that I wanted to call an API. And when I needed to call an API, I needed to figure out how to get an access token. And if I wasn't in an environment where I had Azure CLI or Azure PowerShell, not being able to run like connect AC account or something led to me needing to understand OAuth a little bit, because there are so many different token flows. And if you want a script to run non-interactively as its own service, it's suddenly really tricky compared to just like connecting and running it interactively in the terminal. So I learned about access tokens, started getting those, figured out I needed a custom Auth module, which I'll talk about a little bit later. And then it's a slippery slope, so I'm speaking about authentication now. Microsoft releases a report every year called the State of Cloud Permissions Risks Report, which is a lot of words this early. But it's been released every year for 3 years now, and the 2023 edition came with some numbers. So I want us to play a little game together here, a guessing game. Across the kind of major cloud providers, we have Azure, AWS, and Google Cloud. How many permissions do you think exist across those clouds, like individual permissions? Sorry? No, altogether. 1,000? 100,000. Yeah, that's a good guess. A little high, but we have 40,000, which is 50% of them are considered high risk, which means that anyone with them, with that permission, could cause catastrophic damage if used improperly. Next one, workload identities. How many workload identities do you think on average that we have per human identity? 1? 20? We have about 10 workload identities on average compared to every human identity, every email account that we log in with MFA and such. And this makes it really important that not only do we have on and offboarding for our own human employees, but obviously 10 times more important that we take care of the service principals and managed identities and all those workload identities that we have. This one is fun. Out of all the granted permissions to every identity, how large of a percentage do you think are actually used? 5, 10, 1%. We are giving our identities a factor of 100 times the permission that they need on average, which is great, right? We have how many percentage of identities that are super admins? 80? 50? Good guess. We have slightly above 50% of all identities that are considered super admins being able to control or take over large parts of our environment. And then finally, how many of these identities do you think are inactive, not having been used for 90 days? 80? 90? 60% of them. So I would say this is the state of cloud permissions today. Welcome to this session. So we're going to talk a little bit about identity types. We have a double session in front of us, so we're going to cover most aspects of Azure authentication. What types do we have in Azure? We're going to talk about the credentials that we have, client secrets, certificates, and more. We have applications and resources in the Auth sense, so APIs in Azure. We'll have a break somewhere in between, around 45 minutes, depending on how we're doing. We have permissions and scopes that we're going to talk about. How do we grant permissions? How do permissions and scopes work? How do they work for tokens? What is a token? What tokens do we have? What auth flows are available to us, interactively, non-interactively? Finally, a summary and then some questions was what I thought when I wrote this presentation initially. And then I realized that we're here early morning and it's going to be 90 minutes-ish in front of us. So if you have a question on identity types, it's probably better that we just take it immediately. So if you have a question, raise your hand and we'll try to take it as we go along, get some discussion, and then finally finish up with lunch. Sound good? Awesome. So in Azure, we have two types of identities. We have human identities, which are our normal accounts, the user accounts, as we call them, that we enable MFA on. We have usually an email account tied to an email box. And we have machine identities, which is kind of the opposite category, the non-human ones. These are categorized as two different ones. We have device identities, which are our phones, our laptops, our whatever we enroll in Antwerp, for example, that we control for our organization. And then we have workload identities. Workload identities are any identity run for a specific workload, a script, an app, etc. And we have a few different types of those. But before we talk about which types, let's talk about what a workload is according to Azure well-architected framework. A collection of application resources, data, and supporting infrastructure that function together towards a defined business goal. This is a workload. So a workload identity is defined as an application, a service principal, or a managed identity. So this is the definition I talk about. There is confusion around what a workload identity is. Some people call everything a workload identity. Some people think it's a specific type of identity. And some people think it's a type of federation, which we'll talk about later as well. Now you might be thinking, what about service accounts? Because we have those too, right? Well, if you dig deep enough in the documentation, you will find that Microsoft agrees that there are 3 types of service account native to Entra, which I don't necessarily agree with, but they say managed identities, service principals, and user-based service accounts. Now, it's only really the last one, user-based service accounts, that I agree with, and I want you to stay away from them. So these are normal accounts that we have a username and a password for an application that we log in with, but we can't enable MFA on them, multi-factor authentication, or a lot of other security controls, because we need to run them non-interactively. So then it's better to look at the workload identities and the more proper, maybe secretless authentication that we have, those type of auth flows. Workload identity types. We have now 3 different ones. So let's start with applications and service principals. Applications and service principals are closely tied together. We have a one-to-many potentially relationship there. So for every application that we register, we also get a service principal within that tenant so that it can operate therein. If you work in Azure Portal, you might be more familiar with this, which is app registrations and enterprise applications, which is a terrible and confusing name for service principals, unfortunately. But it makes sense if you register third-party applications, because then it's kind of like an enterprise application. But that's the same. It's just a service principal. Now, if we have a tenant here, we can register an application by taking a manifest or using any of the APIs and register information about it, like branding and credentials and names and API information, and we will get a service principal. And this is for a single tenant scenario. But if we have multiple tenants, if I have an application that I want you to use in your organizations, then you need to consent to my application, or an admin in your organization needs to consent to it if you're not allowed to, based on tenant restrictions. And then when you do, you will have a service principal that my application can act through in your organizations. So that's how that works. Now, we have also managed identities. These come in 2 shapes, 2 flavors. One is a user-defined, user-assigned managed identity, and one is a system-assigned managed identity. The system-assigned is something that you enable for a resource, for a specific service in Azure, on the Azure side as a resource, and it enables that resource to act as that identity. It is backed by a service principal, like a special kind in Entra, which allows us to give it permissions just like any other identity. And it's tied to the lifecycle of that resource. So if we delete the app that we enabled the identity for, it's going to be deleted as well. Now, user-assigned, on the other hand, is its own resource in Azure. So it lives in a resource group, it lives in a subscription, in a management group in your organization on the Azure side. And that also allows it to be affected by Azure policy. If you would want to block these, you could. If you also consider the permission structure in RBAC, in Azure RBAC, which we'll talk about too, these can actually affect these and allow people to connect them to one or multiple resources, because it's not just one resource, it can connect to multiple, which is usually bad practice, because then the more different applications you connect to a single identity, the harder it is to keep track of the permissions and keep track of the security boundaries for it. But it is really useful for scenarios where you need to break the life cycle between a resource and the identity. You need to create the resource first, the identity first, grant it permissions, and then maybe once in a while you repave or redeploy the actual infrastructure that it uses, or that uses the identity. So then you don't have to recreate the identity every time. Both backed by a service principal in Entra. So a quick summary here. We have applications registered in a single tenant, need service principals to operate in that tenant. We have service principals which are created for an application within that tenant. And a small star there is that while it's like a one-to-one kind of relationship there are some discrepancies when it comes to credentials and stuff that we'll mention soon as well. We have user-assigned ones connected to one or multiple Azure resources, and they have their own services, their own resources in Azure. And then system-assigned ones that are fully managed by an Azure resource. Now, all of these have credentials, ways for us to prove that we are the owners of them or that we can act as this identity. And this is what we need when working with this in PowerShell, for example. We need to prove that we are the users of this identity. First of all, we have something called a client secret. This is a password for our application. This is something we generally want to avoid. We get one for free when we create something through the Azure CLI or PowerShell, because it's always been that way. It's hard to change, but also it's good for developer scenarios where you want to get started quickly and try it. But when you move up to test or production, you want to authenticate more securely. So you don't want a password that can leak and be used from anywhere. Then you start looking at certificates. Certificates are ways where we can create a public and private key pair. We upload the public part to our application, and then by having the private key in a server, for example, on-premise or in Azure, we can do a key exchange and ensure that we are the owners of this application and get the token back from Entra. And then finally, something that's very fun, a new-ish year something old credential type, which is called Federated Credential. This is sometimes called a workload identity or workload identity federation, which is really the more pattern of using this type of credential. But the way it works is that we register some information about the third-party platform with our identity, which lets us authenticate with this identity from GitHub or Azure DevOps, which is technically a separate platform and IDP, identity provider. We can use it from Kubernetes, Google Cloud, etc. And the way it works is that we get an ID token for the subject or the identity we want to use it from in the third-party platform. So if we're running a GitHub action or workflow, we can get a ID token for that workflow, send that to Entra. And if we register the information about GitHub and the specific repository and the pipeline or the branch, then Entra will match that with a token, check with GitHub that it's signed, and say, yeah, okay, you get a token back. So it's very nice, it's secretless, and it works wonders for third-party platform integrations, even Azure DevOps pipelines, and it's the recommended way to do so. There are some differences in which one of these that each type of workload identity supports. So we have applications, which support all three. We have service principals, which support only two of them, but not federated credentials. And then how does that work? Because applications, I'm pretty sure I used service principals, you might be thinking, with federated credentials. Well, actually, these are never shown in Azure. You can never see these credentials in Entra, but it is possible to create credentials on a service principal through the API or through the CLI tools that is never shown. So you can do it. It's a way for the application to authenticate directly in a tenant, but it's not really used much, and it's just good to know that there are things that are not shown in the portal. So if we're working with security around identities, we should not really be relying on auditing stuff through the portal to make sure that we're safe. Because if a malicious actor knows their stuff, they know this too. So that's how that works. We have user-assigned managed identities, which can have federated credentials, are managed by default by a certificate hosted by Microsoft on the resource or VM or server backing the actual platform as a service thing. These are valid for 90 days and usually rotated every 45. And same for the system-assigned managed identity, which cannot have any other credentials, only the certificates that are hosted by Microsoft. So you don't really add anything to them. Small thing to note again about the user-assigned one is that if you create this with the purpose of using it from like GitHub or somewhere, it still needs to live in a service, in a subscription in your environment, meaning that anyone with access to that subscription can create a virtual machine and attach this identity, log into it, and use it from there, even though it wasn't fully intended to. So you need to make sure that those, if they're like highly privileged, are also locked down permission-wise. Now, application registrations, one of the types of identities in a way, but also a little bit more, are based on something called an application manifest. This is a way for us to register all the information about our application. We have credentials, like we talked about. We also have authentication information, like where our token should be sent to after the authentication, called a redirect URI. We'll mention that a little bit soon as well. We have configuration like token claims and custom things that we can edit for our application. And we have branding information like uploading a logo, verifying the publisher of the application, changing descriptions, and so on. We also have the ability, as we talked about a little bit, to change between multi-tenant and single-tenant. We can also choose whether we want consumer accounts like our Gmail, Microsoft accounts to be able to use it for certain scenarios. Or setting it to public versus confidential. This is a way for me to tell my application where it's going to be run or used from. A public setting implies that I'm going to use it on a public device. It's something I'm out of control of. It's your mobile devices that are going to use the application. I can't control what's being run there. Someone could listen. I can't be sure that your browser or your mobile phone can store secrets securely. So it's a public application, and therefore you have access to certain token flows that are not as secure necessarily, or not as trusted, versus confidential. It might be a VM on premise behind a lot of like other security controls that we have running just maybe outbound traffic, but doesn't really have inbound traffic at all, as a place where we feel pretty confident that we can store a secret securely. Finally, the biggest kind of thing to understand about an application registration is that it can be both an identity, it can be issued tokens as its own identity, an act, and it can be an API. It can be a token audience where I can go to Entra and say, I want a token for this, my application here, for my my specific API that I'm creating. So it works with both. Now, I think we can go into the portal and just go through the various parts quickly. Here, let's see if it loads up. So if we head into the Azure portal, you can also go to entra.microsoft.com, which is the new Entra portal, if you've used that. I know some people that work with the Entra side like that. We can add an app registration from here or from the sidebar. And doing so is basically a way for us to take all the information in the manifest and start assembling it and sending it to Entra. So we can call it PSConf demo, and we can choose single tenant, multi-tenant things here. Is it large enough, by the way? Yeah. Good. And then we get also options to choose redirect URI. This is important if we want to use it for sending the tokens back to something else than the user. So if I want, there's a difference between using the application as a CLI tool, for example, like Azure PowerShell. The token is always returned to the user after authentication so that the CLI can keep it and store it in memory and use it and cache it. Whereas if we have like a front-end, back-end scenario, we might have a scenario where the user authenticates and then the token is sent to the backend directly from Entra. So that's what the redirect URI says. We can also choose something like public client native stuff, where we can have a specific protocol called my app, for example. There are a few different ones here. Ben, for example, if you were at his session yesterday, talked about WAM, which is Web Account Manager, which is a way for Windows devices to enable single sign-on and such from the already authenticated user when logged into a enrolled device. This allows this type of special functionality where the token is sent to a specific place that is trusted for that flow. In this case, we're just going to register it without specifying a redirect URI. Question?
You think if at your top of your head would be a good example for a multi-tenant app?
A good example for a multi-tenant app is the question. It could be anything that I register that needs access to. If I'm publishing an application that works with your calendar, for example, maybe it's like something that migrates bookings between Gmail and Outlook or something, or your organization, anything like that that needs access to your profile could be a multi-tenant app. Could also be something like ServiceNow or some like SaaS service that people buy. Then the application is hosted by the company owning the service, but you register it as an enterprise application or a service principal in your tenant that acts from that central point.
And if you have a multi-tenant app, then the one who creates it has full control over the app, not you, right?
The question is, does the
add any API permissions to it? So.
Yes and no. So the question is, the person who registers the application centrally, is that the person controlling all the permissions and acting through that? Yes and no. And we're going to talk about that down here called API permissions. But it's a very good question, and I'll touch upon that soon. When we registered our app registration, we get a little bit of information here. The most important thing here is the so-called client ID, which is kind of the username. It's a GUID for our application. Now, this one is what we need to authenticate with this application in every single flow. So this is where we kind of find that. We have the option of, as I said, adding like branding and properties about our application. We can go in and set authentication information. This is redirect URI stuff again that we can add and change, single multi-tenant. And we can also scroll down and allow public client flows, which is a way for us to say that we trust this to run the device code flow, for example, where we have we want to be able to use it on a device that doesn't support web browser authentication. So we want to get the code, typical like smart TV scenario. You get a code and then you log in on the phone and then it authenticates in the back end there. So those type of flows you have to enable. Again, we have credentials, the three types that we talked about. Token config for optional claims, more information within the token for the user if the application wants to read something special. And then we have API permissions. So there are two types of permissions for an application. We have delegated permissions and we have application permissions. If we click here, I recommend doing this through a CLI or some other type of more programmatic way than clicking, of course, but for a visual demo, it's a bit easier. Because here, when we choose Microsoft Graph as an example here, we see we can choose delegated permission or application permissions. Delegated are for the permissions that the application should be able to have if I log into the application. What can it do as me? Whereas application permissions is if it needs to be able to act independently of me on a recurring kind of batch job service or on an event trigger or something like an Azure function doing something on its own. So then those permissions are actually different. So if we go into application permissions, I can say user dot scroll down and I can add something like user read all. This will give it permission to read all users' profiles in my tenant. But on the right here, if it's large enough, I think so, on the lower right, we can see that it's not granted consent. So for applications, we also have the concept of consent, which means that I can grant this application as much permissions as I want. In a multi-tenant scenario, like your question, for example, I can create my own application. I can give it full admin, but it's not going to be able to do anything until you consent that it's able to do stuff in your tenant. And then since when you consent, you also register a service principal within that tenant for your application. You can also control what permissions it has in your environment if you want to. You can limit it, you can add to it. Not that adding to it really affects how the application behaves, but you can look at and ensure that it doesn't have more than you expect, which is unfortunately fairly common to see when registering new like SaaS vendors' applications in your tenants. It might be like quite a few permissions that it asks for because it works and it's easy. It's not least privilege, and I think you should question it where possible. So what I need to do for this to work is I need to grant admin consent for my own application, for my own tenant. We can see at the bottom that the application permission that I added actually requires admin consent. The opposite is a user consent, where if I have a delegated permission that my application can like read your calendar or stuff, then I might allow you to consent on your own for your profile towards this. And it also depends where the application is registered, if it's a trusted publisher and such for your organization. So if I do that, we will see green check marks and we'll be able to use this. I can log in towards it. I can use this, add a credential, for example, and use it from a script, and it will be able to read the user's information. Now, we also have abilities to change and set scopes, and we have a question. Yep.
I think I know the fact that currently they're not scopable. So a user window is meant for all users in the type tenant. Do you happen to know if this is being planned?
So the question is, right now, the scopes for graph, for example, are not so granular. We can say user read all, but we can't say user read all for these 3 people. Is this something being planned? I know that they're working on improving it as like a whole thing because a lot of people are asking for it, but I don't know how it's going, unfortunately. Yeah. But it's important to know that most of these scopes are fairly wide and it's hard to specify a lot of things in graph. So you have to consider that when adding permissions as well. We can add scopes which show up as kind of delegated permissions for this application specifically. So we can specify scopes within our application. We can also add roles that show up as permissions during authorization. And this is more like app, using it as an API scenarios. We can set an owner. I know Miriam talked about this on Monday, where we had a scenario as an attack vector where someone was an owner of an application that had a lot of privileges. So anyone with an owner, as an owner on an application, can manage it fully, add credentials, etc., which lets you impersonate that identity and then act within or as it. And then finally, owner is definitely like a role you should keep track of. Like, it's good to have owners for applications for follow-up and access reviews and those type of things, but you should also consider the fact that adding it as an owner here actually means permissions. The manifest here that I talked about, it's just a JSON blob. We have a bunch of information, all the information that we have in the portal, all the information that we set through the CLIs, it's here. That's it. We can change it if we want. I can go in and say description, PSConf demo, and I can save it, and it's live like this. So this is like the source of truth, really. If we scroll down, we can see the app ID. This is the client ID. We can see all the credentials that we haven't added, but we can see stuff like password credentials, which is the client secrets. We can also see the access that we've given it. This is towards a specific resource, looking like this. This is actually a representation of a graph. You might recognize the GUID. It's a long series of zeros with a 3 and a C in between. And then we can see the scopes and permissions that we've added. So we can actually see the scope here being the, I believe, user delegated permission, and then the role being the application permission. So these are also represented by GUIDs. Yes, question?
Is there a way to report or check if
Is there a way to check where the multi-tenant app has been registered? It's a good question, probably. I haven't worked too much with multi-tenant applications, but I would imagine so. Yeah, it's a good question. Yeah, question.
Yes.
Yeah. 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 All right. That's great. So we have a comment there that it works, and you do it through Log Analytics and App Insights. You said no, yeah. You can see where it's been registered. Great, yeah.
If you look at the sign-in audience property, that's sign, so when you can see if it's for the multi-tenant audience or just for your tenant.
Yeah, you can see if it's a multi-tenant or not. Yeah, you can see that here in the sign-in audience. That's exactly right. So this is a typical single tenant value. Yep.
Also, maybe one limit there, if you create a app registration with the GUI, you have no text set, and then it's not so
That's a good tip. So if you create it through the GUI here, we're not getting the options to set tags, which leaves them empty, and then you can't use tags in a conditional access policy. That's a good tip. Oh, you can't scope the application at all because it requires tags. Yeah, that's even worse. So in general, as I said, I recommend doing the CLI stuff, even though it's visible like this for a demo. Same thing with the thing I talked about, credentials earlier. They're not fully visible on service principals in the portal, so don't fully rely on that. Heading back to some slides. What APIs are there in Azure? We talked a little bit about registering your own. So many. That's it. No, so as an example, we have Graph here. If I want to use Graph as a user of PowerShell down here, maybe, we have a few more parts that come into play when trying to authenticate and use an access token, etc. So we have Entra up here, and then we have an app registration. For being able to use Graph, I need to first get the client ID from my app registration. And if you're thinking, but if I run connect AC account or AC login, I don't really need to get the client ID, right? Well, that's because Azure PowerShell and Azure CLI have hard-coded values that are called well-known client IDs or well-known applications from Microsoft. They are first-party applications registered in everyone's tenant already, so we can use them. And they have delegated permissions quite wide, so they can act as your user with whatever permissions you have through the CLI. And that's why that works, because Azure PowerShell, in this case, sends the client ID or whatever client ID we're using to Entra to get an access token. It says, hi, I want an access token for Graph. I want these permissions. Usually default is good enough, but sometimes you want specific things. And that's what the tooling takes care of for these type of things. Now, Entra is going to check back, did you consent to this application? For Azure PowerShell, yes, we did, because that's like registered already. For a custom one, we might not have. For a multi-tenant third-party one, we probably haven't. So if we have access to do so, we get the access consent prompt saying that this application wants to read this thing or do this and write your profile and calendar. But you might not even be able to consent. In this case, an admin in your organization will have to do that for you. And you have to do like maybe some type of process internally that you've set up. Secondly, it's going to prompt you for login. Once we're consented, we get the typical login prompt in the browser. And then once you've logged in, we get the token back or sent to the redirect URI, which for Azure PowerShell is localhost. So that's why it's being able to pick that up again. And then we can just send an access token with our API request over to Graph. This is what we call them and what we talk about in Azure. But when it comes to OAuth, this is what they're called. These are different OAuth parties where we have a client, we have the authorization server, which is Entra in this case. And this is, of course, true for all types of platforms that implement OAuth. We have the resource server on the right, which is our API, in this case, Graph. And this is why we see stuff like resource ID, resource URL. That's because that's the API, and that's the naming from OAuth. So that's kind of some explanation there. And then finally, the user is actually called the resource owner because they are owning the resource that they're accessing. We have a few different APIs in Azure. We, in this case, can call them OAuth resources, just as a reminder that that's what they are. But all the APIs in Azure are represented by GUIDs. They can have names too, like Graph, for example, has graph.microsoft.com, but is also represented by this really long thing that we saw in the manifest just earlier. GUIDs. We have Azure Resource Manager, also has a GUID that I was too lazy to add, called management.azure.com, which we have to specify when working with Bicep or ARM or Terraform templates, that type of stuff, unless the tooling does it for us. And then we have even Azure DevOps, which doesn't even have a resource URL. It just has a GUID. So if we have to work with Azure DevOps API, we specify the GUID. And that's why you might have encountered this and questioned what the heck is going on. We also have on the other side, those are APIs. We have also well-known applications, which is the clients that we're using when we're authenticating, when we're working with these APIs. Also represented by GUIDs. I have a link down here, which you can get from the slide deck. If you browse that later, it's going to be on the PowerShell ConfEU repo 2024 folder in a couple days. And this lists all the first-party Microsoft applications that might show up in your logs. So if you're curious and wondering what is this line, what is this application that has done something, it's probably a first-party Microsoft app that has gone in, and you can map that to that list. But that list is also useful because you can get all these well-known applications like Azure PowerShell, and you can use this in your own scripts if you really want to, because that's basically what the Azure PowerShell tooling does. Same with the Azure CLI, also has a GUID. And then even stuff like Azure Portal has a GUID, although you can't really use it yourself. It's just good to know that everything is really an application that we're using. So there's no magic going there. There's a JavaScript thing that uses a client ID as well. Now, I think we are, we're almost on time here. We're a couple of minutes short of a break. So do you have any questions here before we stretch our legs a little bit? You what? Yeah, enable MFA. Yeah, some good tips, some wonderful tips, and some necessary ones like the coffee maybe. No, otherwise I think we'll take a break and we'll be back in 15. So be back a couple minutes before, 11? And then we will continue talking a little bit about the permissions. And if you have any questions, we can take them then, or we can chat in between. Thanks meanwhile. So I think we can go to the next slide and simply check. Do you have any questions after the break, now that you've probably had time to sip a little bit of coffee and think about what we've talked about? No questions. Everything's crystal clear. We had one question here during the break, which was, do we see when we have a third party or a first party application created by Microsoft, do we always see it in our tenant as a app registration or a enterprise application? The answer there is we will never see it as an app registration because the application is owned and registered in Microsoft's tenant or one of the tenants. And it will not always show up as an enterprise application. Sometimes they do, sometimes they don't, and it's magic. There is someone like tested that you can actually register your own service principal for a Microsoft hosted application, which is a little bit like fun. And then you can add or edit the permissions and stuff of it, but it doesn't really do anything. But it's possible, and it just shows that everything is like it's built in the same way. There's, apart from this one fact that they don't show up, there's not a lot of magic going on. Usually it's explainable by the same principles of how our apps are behaving. One question.
Have you ever seen environments when they will disallow people to use, for example, Microsoft Graph, PowerShell SDK?
Have I seen
Create an app on their own based on that one and assign it just to a number of admins? Actually,
Right.
just a couple of admins can use it, but for anyone else in the tenant, it's actually
Yeah. The question is, have I seen environments where someone might be blocking Microsoft Graph, the first party application, and then building their own with like restricted permissions or restricted users? I haven't seen it, but honestly, I don't think it's... If you're in an environment where you're worried about how your organization is working, or you want to really restrict it to certain ways of working with, like, if it's a very regulated environment where it has to be compliant with a lot of like laws and stuff, it could be a way to ensure that you're only working with what you're working with. Like, if I'm using Microsoft Graph, I get to use everything therein. But if I have my own kind of restricted graph, you can, I don't remember if you can specify a client ID in the graph commandlet specifically, but you could do it in the Azure PowerShell one, and then you would have the same kind of experience. So
I've seen some steps to do that. I tried it myself. It worked, but I never seen that in real life.
Yeah. So the comment is you've seen it done, but you haven't. Yeah, you've seen the theory, but you have never seen it done at the customer or such. Yeah, never seen it either, but I see the reasoning a little bit. Sure. Yeah, let's talk a little bit more about authentication, and let's talk about permissions. So permissions are structured a little bit differently depending on which part of Azure you're working with. We have, I consider them to be like two separate sides. We have Graph on one side with all the permissions that it has and that we talked about a little bit before. And then we have ARM or Azure, the Azure Resource Manager, where we deploy resources on the other side. But then Graph also contains like Entra, and then we have Container Registry and Key Vault and storage and all these like separate data plane APIs everywhere else in Azure. And then we have Azure DevOps on the side, which is its own thing, still implements OAuth and works similarly, but kind of differently. And then Cosmos DB, which is also like a data plane resource. So we have all these different APIs, but since all of them use OAuth, we can consider them to be working the same. Now, they don't necessarily use the same tokens, but if we trust our tenant through Azure DevOps, for example, we can mostly work with the same accounts and such. And since a year-ish back, we can also use service principals and managed identities and such in Azure DevOps. So that's good. But they differ a little bit in permissions. So let's talk about Graph first. Again, we have the graph.microsoft.com, which is the resource URL that we have to specify when working with it. Most tools have it as default, so we can just kind of connect AC account or something. it's an API with a lot of APIs within. That's the easiest way to say. We have Entra in there, we have SharePoint, we can work with lists and sites, but we can also work with Intune devices if we want to, and so much more. Now, applications, as we saw, are granted permissions. App registrations with Entra have either delegated or application permissions, and these permissions need consent. But when it comes to identities or groups in Entra, not applications, those have roles instead. So I can be an application administrator, or I can be a global administrator, or user access administrator, or those type of roles. And those have individual permissions within those roles too. You can have either built-in, the ones I mentioned, for example, or custom roles if you have P1, P2 licensing, which you probably do. And then you can build custom roles in Entra or in Graph with specific permissions. Now, what about workload identities? Because they are kind of identities, and yes, they can be assigned groups or roles too. So you can add application permissions to an application, or you can add its service principal to a group. And it's confusing and complicated and kind of dirty, so I think we're moving on. We have Azure Resource Manager on the other side, which is our way to create resources. We have the infrastructure side of things and all the PaaS and EOS and services, like storage and VMs and databases and stuff. It's using something called Azure RBAC, Azure Role-Based Access Control. And these roles are defined kind of with two different resources also. So everything in Azure on that side is a resource. Policy is a resource, all the infrastructure is a resource, and roles are a resource. So we have role definitions, which have three parts to them. We have role definitions which have permissions. It's the assignments that have three parts. These have either actions or not actions, and or not actions, and we have data actions and not data actions within that role definition. So this allows us to define with wildcard, if we want, to say that I want a role with */read. It's going to be able to read all the resources in Azure within the scope I assign it to, but then I can also exclude things from that role. So it's going to have */read, but not on networking. So it's going to get all the permissions except for networking. There's no way to block or deny permissions with this. It's only an exclusion from this role. So if you stack another network role on top, you're going to get the network too. Same thing with the data actions and not data actions. And the difference here is on the control plane versus the data plane. The control plane in Azure is where we manage our infrastructure and the security settings and networking and such. We can set HTTPS requirements on a storage account there, but we can't read the data there. So the data is in the data plane, which would be like the contents of a database, what's inside the key vault, those type of things. So we can still manage the key vault on the control plane, but we can't read the contents. For those actions, we have data actions or not data actions that also work the same. We can specify with wildcard and then exclude some, or specify as granularly as possible. Something to note here is we have built-in ones and we have custom ones as well, but Microsoft hasn't, in the pace of services being released and created in Azure, there's a lot of roles that aren't even available for new services. So if we look at, I think it was like container apps or container instances or something that I saw not long ago, as an example, there is no really built-in role for it. You get it through like owner and contributor and the high privilege roles, but there's no, I might be wrong in this, but as an example then, Azure Container Apps contributor or operator role. And you could create them yourself, which is these days best practice, because if you are working with built-in roles only, there's a good chance we're overprivileging our identities, which we are, as seen before. Now, to assign these roles, there are three parts. We have the scope, which could be a subscription, a management group on a very high scope, could be a resource group with a number of resources, or a specific resource itself. So I can grant access to a specific storage account if I want to, which is preferable wherever it doesn't create a lot of management overhead and like complexity in terms of governance. We have a security principal, which is a word to say we have an identity or a group or something to add this permission to. Someone will be granted this permission. And then finally, we have a role definition. So one of these, a scope and someone to grant it to, is what we need to make a role assignment. I'm not talking about PIM today so much. PIM is a privileged identity management, which is a way to get just in time or activate our permissions for a limited time with options of having approval. This is something we should look into as well when it comes to all these privileged roles. As an example, we have the owner role here. This is a built-in role. It has star as control plane or management plane, as some people say, permissions, which allows it to do everything, including add more roles. So even if it doesn't have data plane roles, it can add it to itself by other roles. And this one contains about 17,000 permissions. So think about that. Now, we talk a lot about least privilege. Least privilege, or the principle of least privilege, means that we have to or try to abide by the fact that we need specific permissions as granularly as possible on specific scopes. So we don't add owner on a high scope like a subscription, but we add contributor or like a specific operator role for a resource group or a resource where possible. But sometimes it's hard to say what this privilege is. If we take an example in Azure, sometimes we have to take a step back and look at the kind of neighboring platforms, because if we look at Azure and a subscription, for example, we can add owner there. It says grant full access to manage all resources, including the ability to assign roles in Azure RBAC. This is extremely privileged. It doesn't, like, there is no higher role in Azure on the RBAC side. But we have on the graph side or Entra side also roles like application administrator, which lets someone add or configure or change app registrations and all the credentials on them and enterprise applications, which is potentially more dangerous because then you can do it on all applications. And maybe if one of the applications is owner, then you can impersonate that by adding a credential, etc. But then we have in Azure DevOps another admin role called the Project Collection Administrator, which allows you to perform all privileged access operations on the team project collection. This is basically full admin in Azure DevOps. And if Azure DevOps has a bunch of connections to our platform, that's sensitive. That's more sensitive than maybe owner on a subscription. So you really have to take a step back. As an example, well, it's hard to figure out which one is which and which one is least privilege. It's kind of the summary of that slide. As an example, we have Azure and Azure DevOps, two different platforms, neighboring and trusting mostly. We have resources, maybe a resource group here with a service principal, technically living in Antwerp, but I wrote it in Azure, it's fine. We have an Azure pipeline and a repository in Azure DevOps, where we have the code and maybe define it as a YAML pipeline or something. Excuse me. In the Azure side, we have given permissions to the service principal to work and deploy these resources, to write to these resources in the resource group, which is typical. And then we might have set up a service connection from Azure DevOps to Azure, so that we can utilize this new connection, this new identity that we created to deploy things from maybe our repository. Now, this repository is sensitive, and anyone, such as a developer, being able to work in this or contribute code to this repository is also effectively able to impersonate this service principal. That's why we have stuff like branch policies and other types of security controls. But anyone also able to add or modify the service principal can do this. So we have another vector over here with someone administrating Entra, being able to add credentials such as the application administrator before, because they can add a client secret and log in from their own computer based on conditional access and stuff, of course. to modify, destroy, delete, override, or extract data from these resources. And then we also have another one, such as the platform engineer or the administrator of Azure DevOps, being able to override security controls and branch policies and set up new pipelines or new branches and use pipelines from there, and security connections, being able to take over this identity and use it. So it's not only this identity per se that we need to protect, we also need to consider all the vectors that can use it. These should preferably use PIM for activating their privileged roles, of course. But for the developer, it's hard, so we need to trust and implement pull request flows and security scans and everything in between there. I'll let you take a picture for a moment here. Now, who can tell me what this is? Yeah, access token. Correct. It could be another token probably, but considering the payload, probably an access token. This is what's called a JSON Web Token, JWT. It's a format where we encode some content which is in JSON, and we encode it as base64, and we put it together, which allows us to send it over the internet without encoding issues and that type of thing. Now, it comes in three parts, which is the header in red here, some information separated with a period to the payload, which is most of the information in it, separated with a period to the signature, which is our way to validate that it's actually real. No one modified it or faked the token or anything. So the header, if we decode it, looks a little bit like this. This is a JSON format, you might be familiar, which has so-called claims. This is the type. They come in 3 letters only, so allows us to see that it's a JWT, it's the format of the token. It's letting us know that it's using the RS-256 algorithm for this token to validate and sign it and such. And we have the KID or the key ID, which Entra adds to let us know which key it used to sign this token, so that we can go to Entra and say, hey, I want to check your public key called this, so I can validate that this token was actually signed by you. And that's what the tooling does for us. Next, we have the payload. Very small. I already shortened it, but I couldn't really remove too much without it just being some information. All of this is called claims. Anyway, these are key value pairs, just like a hash table, but in JSON, that we have in our token. This is like the body of our token. It has an audience up here called the graph in this case, which is the default. We have an expiration date. We can see when this token is no longer valid. We have an MFA claim to show that I actually logged in and used multi-factor authentication with this token. We can see which client was used, in this case, Microsoft Azure PowerShell. And we can see my name, my UPN, my IP address, and all the scopes that I asked for in this token. So this is what's sent to my application, and it's what the application will use to authorize me and try to ensure that I have access. We also have the signature, finally, which is the last part. And the signature is base64 coded and encoded header separated with a dot with the payload also encoded, which is then hashed, which is a way to just shorten it so that we don't have to use all of this data in the signature every time, because then it would be a very long token if we have to duplicate everything. And then we encrypt it with a private key, or rather Entra encrypts it with its private key. And then the question is, which private key? Well, that's what we have in the header. So we can, by looking at this one, if we decrypt this with the public key of Entra, because it's a key pair, we can match this hash with simply encoding it, separated, and hashing it ourselves. If those hashes match, we know that the token is valid. So that's how that check is made. We have a couple of links here at the bottom as well. Every tenant, as well as the common login tenant, has a configuration for OpenID Connect, which you can browse and log into and look at the keys and everything. So even your tenants, even if you feel like they're kind of hidden or something, everything is public when it comes to the key configuration. That's how we can trust the OAuth parties between different platforms. That's why we have the federated credentials being able to work, because Entra can check the keys that were used by Azure DevOps or GitHub and check that the signature actually matches the ID token that it received. There are a few different tokens. We have the access token, which we just looked at, typical with claims like scope and ID and client and app and expiration date and such. And this is sometimes called a bearer token. It's because the bearer of the token has full access. You don't need anything else. You don't need like an extra password or a username or anything. You just have that token, and then you can call the API. You put it in the authorization header with like bearer and then your token. It's used for authorization. It's used to call APIs. And then it's also short-lived. So these are also usually just valid for about an hour before they expire. So what do you do after an hour? Well, you have another token. You have a refresh token, which is a way to refresh other tokens. It can refresh access tokens when they expire, basically ask for a new one. You never really change the current one because it's already signed. It's immutable. If you change any of the content, the signature no longer is valid. These are very sensitive and they're long-lived because they can refresh tokens. They can not only refresh access tokens, but they can also refresh themselves. So on a device that is enrolled to your organization, for example, you have something called a primary refresh token, which is stored securely on your device. And it refreshes itself to keep up things like single sign-on to your organization, those type of things. And finally, we have an ID token. The ID token is something that came with OpenID Connect, and it's used for authentication. So this is proving that you are who you are. This is what, when we talk federated credentials or workload identity federation between platforms, again, one of the credential types. This is a way for us to basically trust between third parties as long as they implement OpenID Connect, which is an extension of Auth 2, which is kind of the standard of identity protocols today. Also short-lived, so they don't last super long, but they are also not incredibly sensitive. Not like access tokens, you can't actually do API requests. However, if you get an ID token that is registered for another type of auth or trust, then of course it is sensitive in that sense. Now, I wanted to take a moment to plug a module that I built, which is called AC Auth. It's a module that I built to support all the flows, all the credential flows, such as AC accounts, but it also comes with custom caching. Sometimes I found myself in scenarios where I wouldn't say that the tooling failed me necessarily, but I would say that I had use cases that weren't really in scope for Azure PowerShell. If I had a module that I wanted to implement authentication for, but I didn't want to take a dependency on the Auth module or the Azure Accounts module, and I wanted to have a refresh token cached for myself, then I didn't really have any tooling support. So that's why I built it. It comes with all the typical auth flows like interactive browser. We have device code. We have client secret for developer scenarios, client certificate and client certificate path for Windows/Unix file-based private key storage. Managed identity support and workload identity federation, where we can send the ID token from something like GitHub, as well as a token cache, as well as some other parameters where we can decide like resource and timeout, scopes, and claims. So I wanted to take a moment to have a look at this and how it interacts with something like the Azure CLI. So is that large enough for people in the back? Awesome. Then if I just start with disconnecting myself from the AC accounts and Azure CLI, just to show that I'm not logged in anywhere, I can run get AC token, which is the command from my module AC Auth, and it's going to fail because we haven't logged in anywhere. So after this, we can run get AC token interactive. And the reason I showed that it failed will be more apparent in a moment. So if I run interactive, it's going to pop up a browser just as we're used to, and I can log into my demo account here. We get the authentication complete, pretty much similar experience, and we get the whole token here. We can see that it's for graph, which is the default. And we can also see the scopes and which account with identity here. Now, if I want to, I can run get AC token again, and it caches the token within this session. This is used by the MSAL library, or it uses the MSAL library, which is the Microsoft authentication library that all these modern tools uses. So all the tokens that we get here are equally secure as with Azure PowerShell and such. Now, this works, and it's for a single session, but then if I change session here, another tab that I've pre-opened for the next part of the demo, this is fresh. If I run get AC token, it's not going to work again because I'm in a new session. I haven't cached it anywhere else. There's no token persistence yet. But something that I wanted to be able to do was to get tokens from other tools as well. So if I run connect AC account with Azure PowerShell, I can connect as we expected with the new login experience that Damien will talk more about later. I can run get AC token, and it's going to check, do I have any tokens in my session, or do I have any tokens on other tools on my device? In that case, I'm going to take one of those tokens. So if we have a look here, we can actually set clipboard to copy this, because I don't trust myself marking things on such high fonts. I can go to jwt.ms. I'll just refresh this. This is Microsoft's token parser, basically. It lets us decode the token and separate it in things. And if I paste it in here, we can see that it's for graph, the audience here. Maybe I can do this for you. We can see that it's actually for Azure PowerShell. So I took the token that the PowerShell module was using or had cached. Now, same goes for the Azure CLI. So if we disconnect AC account, we can see that it's no longer working here. And then we can log in with Azure CLI instead. I think actually I might have to, I have to add allow no subscriptions because I haven't given this demo account any access. So going back here, I have logged in. I get to choose like my tenant. I'm going to click enter. And then if I get AC token and set the clipboard again, I will be able to get that token and we can have a look at the contents. So scrolling down here, we can see that this token is actually from the Azure CLI, which I haven't really done anything with my module. I just read from their caches, which is neat, but not super useful per se, unless I just want that to be available for the user. So if I log out here just to prepare for the last demo, we can see here that if I run interactive, I can also specify a token cache. So I'll call it PSConfEU 2024. And after this interactive login, it pops up here. I'm going to get, never works live, right? See, there. I'm going to get the token. But the beautiful thing here also is that I can get this token from a specific token cache, like this. I need to specify a username for the cache. So I can specify a cache, and it's going to take an access token from that cache by string. And for the usernames, I can get tab completions for the accounts they're in. So I'm going to use this, and it's going to be pretty much instantaneous for getting a new token from the cache, which is session persistent as well. So it has support for both getting tokens from Azure CLI and PowerShell, but also for custom caches. And the custom cache stuff is really useful when you want to bundle it with existing modules. So, for example, we have a module, Björn, another speaker here, has a Azure DevOps module for working with Azure DevOps API. But for that, we first took a dependency on the Azure PowerShell module for the authentication part. That became a little bit clumsy when it came to contexts and such, because someone was working in Azure PowerShell and logging in and changing tenant and changing subscription, and then worked a little bit towards the Azure DevOps API. Now, that was kind of fine, but suddenly the user experienced this magical token that was working didn't work anymore because they had disconnected from the Azure PowerShell, for example. So we figured that we needed our own authentication somehow. So we ended up building a connect ADOps, Azure DevOps command, which uses its own token cache so that we're unaffected by any changes in the Azure PowerShell context. Yeah, question. So this one here that we see on the screen that you can copy and log in with is actually an access token. But when we use this command up here, when we log in interactively or with device code and we specify a token cache, then we're going to take the refresh token that we get. We always get one unless we tell Entra that we don't want an a refresh token. Then we're going to take the refresh token that we get and we're going to store it in a cache. And that's encrypted on the device according to the way that MSAL does it, which is the library. Yeah, it serializes it in a cache. Absolutely, yes. It's persisted across sessions, and it's in on your disk, basically. While on Windows, it's in the Credential store, I believe, and on Mac, it's in the keychain, Unix-based. Same with Unix. So it stores it there, same way. And that's also why the module can read from the other caches, because they are also stored there, as long as it's the same user and such. We also have like a clear AC token cache command if I want to clear a specific token for the purposes. And those two commands are everything that the module contains at the moment. Doesn't have full support for WAM yet, but is coming, but otherwise supports all the token flows needed. So that's a little bit about what I've been doing with that tool. Now, to summarize, I think it's complicated, right? We have a lot of moving parts. There's so many aspects to authentication. We have not even covered stuff like access policies, conditional access. We have all the device stuff, right? I'm not an Intune guy, but there's plenty of stuff that you can do for protecting your tokens once you have them. Microsoft has something called token protection with something new called token bindings, which allows us to ensure that the token that we get can only be used from the device that it was received it. And this is really good stuff, and I think you should look into it. I know Damien is going to talk a little bit about these things too later on. There's just so many parts, and we only had about 90 minutes, so I figured I'd touch on the things that I figured was vital to understand. Now, or just interesting. Recommendations. Don't rely on the Azure portal. That's like one big thing. Like if you're really wanting to ensure that you're like secure, you want to check the permissions, you want to see the credentials, use some other proper tooling, because we can't rely on the Azure portal fully. We don't see everything, and it makes sense because there's so many things being built, and Azure Portal is only like one app. It can only build so much to keep up with all the other services being requested and built in Azure in a way. So use some type of API tooling, and use proper tools to alleviate complexity overall. Like if you if you didn't know that you needed a client ID to get a token, for example, it's because Azure PowerShell and Azure CLI has done a good job of like simplifying that flow a little bit. So if we're using delegated permissions and getting tokens for ourselves when working hands-on in Azure, use tools that support that flow, and stop making your identities overprivileged. Thank you.